So one of the things we need to be able to do to pass chemistry is to write balanced chemical equations. So these are the steps. The first thing is to write a skeletal equation by writing the correct chemical formulas for each of the reactants and products. Sometimes the problem will just give you a sentence. They'll give you words and names of chemicals, and you have to write the formulas. That's Chapter 5 stuff. So if you haven't studied up on Chapter 5, now would be a good time to do it, because as so many things, we talk about a topic and then it comes around later. So brush up on your nomenclature. So next, if you get an element that happens or occurs only in one compound on both sides, balance that one first. If there's more than one, balance metals before nonmetals. This is a suggestion only. That's just a suggestion. If you have an element that occurs as a free element, so like O2 or iron, just Fe, if you have one of those on either side, that's a good one to leave till last, because when you balance that one, it's not going to mess anything else up. And then after you've got things balanced, if you've got coefficients that are fractions, you need to clear those fractions by multiplying the entire equation. If you hate fractions, you can balance chemical equations without doing any fractions. So don't worry about that. Last thing is check your work. Okay, go back and look at it again. Actually count how many of each atom on each side and make sure that it's really balanced. So here's a thing to do and a thing not to do. Do change the coefficients to balance the chemical equation. Do not change the subscripts. H2O is the formula for water. You can't make it be H3O just because that makes the balancing of the equation simpler. You've changed the compound and you can't do that. Let's do a bunch of examples. Write a balanced equation for the reaction between solid chromium-3 oxide and solid carbon to produce solid chromium and carbon dioxide gas. So this is one of those problems where they're giving us names, and so the first issue is writing formulas. To write a formula for a compound, we first have to recognize what kind of a compound is it. So here's chromium-3 oxide. Our choices are ionic, molecular, binary acid, or oxyacid. Ionic. The Roman numeral is a dead giveaway. If you see a Roman numeral, it's ionic. Those are the only compounds that have those in their names. The other dead giveaway is chromium is a metal. It starts with a metal, it's ionic. So chromium, I'm going to make some little notes to myself. Chromium 3 would be Cr3+. When we're writing formulas for ionic compounds, we have to consider the charges on the different ions. And oxide is from oxygen, and what's the charge on oxide ion? -2. So I see that these charges are not the same. So if you like to crisscross, we could do it that way. We're going to end up with Cr2O3. And that's how the charges will add up to 0 if we have 2 chromiums and 3 oxygens. So Cr2O3. This doesn't specifically say to include state symbols, but I'm going to because they gave us the information and it's good practice. So this is a solid. The reaction between this and that. So the and is like the plus. What's the formula for carbon? Just C. What you have to ask yourself is that one of the 7 diatomic elements? Horses need oats for clear brown eyes. Now chlorine is diatomic, but carbon is not. So that's just C, and we're told it's a solid. To produce, so this and is like the plus sign. To produce is the arrow. Solid chromium and, another plus sign, carbon dioxide. What's the formula for chromium? Just Cr. It's a metal. It's not one of the diatomic elements. And the state symbol is solid because they told us it's a solid. I am having issues with my stylus. Carbon dioxide gas. What kind of a compound is that? It's a gas. Is it molecular or ionic? Is it an acid? It's molecular. So carbon. The first element is carbon. We look at carbon, we find on the periodic table it's a nonmetal. And the prefix di also suggests that it's molecular. So carbon dioxide, there's no prefix on carbon, so that's just one carbon. Dioxide means there's two oxygens, and it's a gas. So there's your review of nomenclature. Now we have to balance this. The technique we're learning is called balancing by inspection, which means you inspect it or look at it, and you just figure it out. So one way you can do this is by kind of taking inventory down below. So what I'm going to do, and if you like this technique, go ahead and use it. If you don't, then don't use it. I'm going to look and see what are the different elements that are present. I've got chromium and oxygen and carbon. And so I'm just going to write those down here. Chromium and oxygen and carbon. I like to just write them in the order that I find them. And then I'm going to look in this formula, how many chromium atoms are there? There's 2. So I'm going to write 2. And how many oxygen atoms? 3. And how many carbon atoms? None. And then I'm going to look at carbon. How many chromium atoms? None. How many oxygen atoms? None. How many carbon atoms? 1. You might say, this is dumb. Let's do the other side. 1 chromium, no oxygens, no carbons. We look at CO2, we've got no chromiums, 2 oxygens, and 1 carbon. That's not too hard, is it? We're just counting up the number of atoms in each of those formulas. Now, what we want to happen is we want 2 plus 0, that equals 2. And over here we have 1 plus 0, that equals 1. We want the sum on each side to be the same number. It's not working out right now for chromium, is it? So they gave you guidelines about, well, if it occurs only once on each side and blah, blah, blah. My experience has been that if you start with the first element and just work your way through, most of the time that works fine. So let's just do that. Let's try to fix up chromium. So I have 2 on this side I drew this line here because this is the reaction arrow. I've got 2 on the left side of the arrow. I only have 1 on the right side of the arrow. I can't take anything away. All I can do is add. If I made there be 2 chromium atoms, then that would change this to a 2, wouldn't it? And it's not going to change the number of oxygens or carbons because there weren't any. Now I've got 2 plus 0 equals 2. So I have 2 chromiums on each side. Are the oxygens balanced? 3 plus 0 and 0 plus 2? No. So on the left side, let's go ahead and just do the adding. On the left side I have 3. On the right side I have 2. Well, I need more oxygens on the right side. Can I make this into CO3? No, it has to be carbon dioxide. I can't change the formula. Well, I could say, I guess we'll have to make there be 2 of those. I'm going to avoid doing the fractions. If you want to see how to do fractions, talk to me outside of class. If I make this a 2, though, that changes things down here, doesn't it? The chromiums are the same, but now I've got 4 of those, and I've got 2 of these. So now I've got 0 plus 4. I've got 4 oxygens. Did that solve my oxygen problem? No. Okay. Now I need some more on the other side. Well, what if I put a 2 here? Add another one of those. Okay, that's going to change several things, right? That's going to change the number of chromiums. Now how many chromiums do I have in there? 4. Because I have 2 of these molecules. So now I have 4 chromiums, and how many oxygens? 6. Does it change the number of carbons? No. Okay, so let's fix all these up. Now I've got 4 chromiums and I've got 6 oxygens. And so we say, dang, I messed up my first line. Like, well, I'm gonna stick with the oxygens for now, and I'm gonna go back to the chromium. Sometimes this happens. Okay, so now I've got 6 over here and 4 over here. Like, man, we're going in circles. Well, what do I need to do here? I think of carbon dioxide as being like a bicycle. And this is telling me I want to have 6 oxygens. I want 6 wheels. How many bicycles do I need? 3. See, that's no problem. So I'm going to erase this 2, because that didn't work. I'm going to put a 3 here. So that gives me 6 oxygens and 3 carbons. You see what I'm doing? It's not rocket surgery. And this is 6. Okay, now I've got the oxygens. I better go back and look at chromium because I fixed it and then I messed it up again. That's why you often want to leave these guys to themselves. So over here I've got 4 chromiums and now I've only got 2 over here. But that's not going to be too hard to fix, is it? I just need to change that 2 to a 4 and everything should be okay. So we'll get rid of that and make it a 4. Now I've got 4 chromiums and no chromiums, and that adds up to 4, and I got 4 on both sides, and that's good. Now we need to get to carbon. So carbon on the left, there's only 1. And carbon on the right, after all my messing around, now I've got 3 over here. How can I fix that? I need to put a 3 in front of carbon on the reactant side. That doesn't change the chromium or the oxygen, it just changes the carbons. Okay? So we balanced it. I didn't end up with any fractions, but let's go and double check. And so I'm going to look at this. I've got 2 of these guys. So that's 2 times 2. That's 4 chromiums over here and 4 chromiums over here. I've got 2 times 3, 6 oxygens. And over here I have 3 times 2, 6 oxygens. I've got 3 carbons and 3 carbons. Bingo! It's balanced. When you first start doing this, it's going to be tedious, okay? And you might get lost a few times. Just scribble out what you were doing and start over again. If you know, I went around in circles a little bit on the oxygen here. If you go around the tree like 3 or 4 times and you're like, I don't think we're getting anywhere here, maybe you have one of your formulas incorrect. If this formula or that formula was wrong, if the subscripts were wrong, it might be impossible to balance the equation. So if it's looking impossible, make sure that your formulas are correct. Let's do another example. Balance equation for the combustion reaction of gaseous C4H10 and gaseous oxygen to form gaseous carbon dioxide and gaseous water. There's a lot of gas. Too much chili, perhaps. Okay, so the first one, they gave us the formula because we don't teach you how to name that guy. So that's C4H10. I'm going to include the state symbols just because I can. And that reacts with gaseous oxygen. What's the formula for oxygen? O2. Oxygen is a diatomic element, and this is where you need to know that. Horses need oats for clear brown eyes. All of those elements, if they're by themselves, it has a 2 subscript. If it's in a compound, it's just whatever it is. The 2 is only if they're by themselves. So here, oxygen's by itself, it's a gas. We have our arrow. Carbon dioxide, we already figured that one out. CO2 is a gas. And gaseous water. What's the formula for water? H2O. So what do you think of the tally inventory method? Like that? Not like that? Don't like it? Okay, I showed you that once. I'm going to show you the other way then. So this is just doing it by inspection without writing a bunch of stuff down. So I'm just going to start over here with carbon, and I'm looking, and there's carbon just over here. So 4 carbons, and over here I've only got 1 carbon. So I can see that if I multiply this by 4, I could make it be 4 carbons. So I'll put a 4 here in front of the carbon dioxide. So the carbons are good. And here's hydrogen. There's 10 hydrogens. And over here, I have 2 hydrogens. So I need to multiply 2 by a number so that I can get 10. It's 5. Okay? So I've got 2 of them taken care of. Third one, here I've got 2 oxygens. And over here, I've got oxygen all over the place. I might want to write something down here. So here I've got how many oxygens in 4 CO2s? 8. Because each of them has 2 oxygens, and I've got 4 of them. And then in the 5 water molecules, how many oxygens? 5. So I've got 8 plus 5, and last time I checked that was 13. So I need to make this into 13. But they're coming in pairs. How do you get 13 shoes at the shoe store? They make you buy pairs of shoes, right? So here I have an odd number, and here I have an even number. This is what I call the odd-even problem. You can solve this with a fraction. I'll just real briefly tell you how. If you multiplied this by 13 halves, you'd end up with 13. Your equation would be balanced, but then you have to multiply everything by 2 to get rid of the fraction, because we can't have fractional coefficients. Or, what I recommend for most of you, you have an odd-even problem. What happens if you multiply an odd number by 2? It becomes an even number, and the problem disappears. So what we're going to do is we're going to multiply everything by 2. Okay, so I'm going to put a 2 here. This is the one I'm debating over, so I'm going to leave him alone, because this is what I'm working on. And then I'm going to make this be 8. And I'm going to make this into a 10. You might say these numbers are getting big. It's okay. Sometimes they're really big. And what does that do? Now I've got 16 oxygens in the first one and 10 oxygens in the second one. And that gives me 26. 26 is an even number. What do I multiply 2 by to get 26? 13. So I need a 13 here. That's the odd-even problem. So then I check it. 2 times 4, 8 carbons. 8 times 1, 8 carbons. 2 times 10, 20 hydrogens. 10 times 2, 20 hydrogens. 13 times 2, 26 oxygens. And here I've got 2 times 8, that's 16, plus 10 times 1, that's 26. Any questions? This is something that takes practice. Here's another one. Write a balanced equation for the reaction of aqueous lead-2 acetate with aqueous potassium iodide to form solid lead-2 iodide and aqueous potassium acetate. A good way to practice, especially if you're like, I don't know about this, go to the YouTube video, get to the point where I am right now, where I'm just stating the question, and try to do it yourself. Pause the video, try to do it yourself. And then if things went well, you can check, just go forward. If things don't go well, just go a little bit and get some clues as I explain it to you again. I'm very patient on those YouTube videos. over and over and over again. Okay, so here we have aqueous lead 2 acetate. What kind of a compound is that? Ionic. So to write the formula for an ionic compound, I want to write down the ion formulas first. Lead is Pb, and the Roman numeral 2 tells me it's 2 plus. Acetate is something you have to memorize. C2H3O2, and it has a -1 charge. Just because. That's its name, that's its formula. So when I put those together, I'm going to need 2 acetates to balance the charge on lead. The purpose of this is not to teach nomenclature, so I'm doing that quickly. So I'm going to have a 2 over here, and it said that's aqueous. That's a 2. So I'm going to put AQ. And then aqueous potassium iodide. So potassium is a metal, so this is also ionic. Potassium is K. It's in group 1A, that's why it doesn't have a Roman numeral. So I know because it's in group 1A, it has a charge of +1. Iodide, that's a monatomic ion. It has a charge of -1. So that guy's easy. I just need to push those together. Ki, that's aqueous. To form, there's my arrow. And now I've got lead 2 iodide. Okay, we already saw lead 2. He was Pb2 plus. And we already saw iodide. And that's convenient. So based on the charges, I need PbI2. And it says that's a solid. And the other product is aqueous potassium acetate. And I did not plan my spacing very well here. Potassium's K plus, acetate C2H3O2 minus. So just one of each. K C2H3O2. And that's aqueous. That's the first step. Write the skeleton equation. Got to have the formulas correct, though. So we will learn later, this is a double replacement precipitation reaction. You see this C2H3O2, the acetate ion, is all together over here, and it's all together over there. The acetate ion stayed together. It just switched places. Here it was with the lead ion, and now it's with the potassium ion, but it's still acetate. That means I can balance that as a unit. I don't have to look at carbon, hydrogen, and oxygen separately. You can. You can do it by individual elements. Okay, same kind of thing we did with the previous 2. Or we can think of that as a unit. So here I've got 2 acetate units, and over here I have 1 acetate unit. I need there to be 2 over here. How do I do that? The only thing I can do is put a coefficient in front of it. So I could say, well, I must have 2 potassium acetates. That gives me 2 acetates over here and 2 acetates over there. If you're balancing by element, notice that it also works out 4 carbons and 4 carbons, 6 hydrogens and 6 hydrogens, 4 oxygens and 4 oxygens. I skipped the P. What about the P? PB, sorry. 1 PB and 1 PB. So he's good. What about K? I have 1 potassium, and over here I have 2. So I need a 2 in front of this one. And then the last element to check is iodine. 2 I's and 2 I's. Cool. Took care of itself. And then you should go through and check it. Any questions? Here's one where the formulas are given to you. Makes it a little easier. Takes out that whole first step. Let's balance this one. I'm going to go back and I'm going to do the tallies on this one. So I've got H, Cl, and O. Those are my 3 elements. So I'm just going to keep track of them. There's H, Cl, and there's O. That's not a very nice O. I'm going to do better than that. Maybe I can't. There we go. Okay, so in HCl, I've got 1 hydrogen, 1 chlorine, and 0 oxygens. In the O2, I have no hydrogens, and no chlorines, and 2 oxygens. Here's my arrow. This is the dividing line. And then in water, I have 2 hydrogens, and no chlorines, and 1 oxygen. And then in this Cl2, no oxygens, 2 chlorines, and no oxygens. You okay with how I did that? If you don't like the tally thing, balance it the other way and see if you come up with the same answer I'm going to get to. So the hydrogens, 1 plus 0 is 1, and over here I've got 2. So I need to put a 2 in front of HCl to get the correct number of hydrogens. If I put a 2 here, that changes this, and it changes this, and multiplying 0 by 2 doesn't do anything. Now I've got 2 oxygens on the left and 2 oxygens on the right. The chlorine, I've got two chlorines over here and 2 chlorines over there, so that's cool. Sometimes that happens and you don't have to do anything. And then let's look at oxygen. I've got 2 oxygens on the left and only 1 on the right. Shoot. Well, I'm going to have to put a 2 here because I want 2 oxygens down there, but that's going to change the hydrogens to 4. So I fixed the oxygens, but I messed up the hydrogens. Okay, so let's go back and fix the hydrogens. Now I've got 4 hydrogens, and so I'm going to have to change this 2 to a 4. And so that's going to change this, and it's going to change that. 4 and 4. So the hydrogens are good. Now I messed up the chlorines. All right. It's okay. It's okay. We can do this. 4 chlorines and 2 chlorines. Thank goodness this guy's all by himself. Just chlorine. So when I change the coefficient on this one, it's not going to mess up another element. That's why we often want to leave something like that for the end. So if I put a 2 here, that'll only change the number of chlorines, and that will fix it. So one of the frustrating things about balancing chemical equations is I can't give you a specific set of rules that will be the easiest way for each equation. It's like with children. You have to do what's right for the individual child. There's not one right thing for all children. This makes life interesting, I suppose, but frustrating to some of us. So start balancing the equation. If it seems to be going badly, you're like, I'm not getting anywhere. After you check your chemical formulas, start over in a different place. So, I went about this by doing hydrogen and then chlorine and then oxygen. In retrospect, that maybe was not the easiest way to do it. So if I got bogged down in here and got lost, I could just start over and start with something else. Any questions?